Hi everyone, welcome back. Today we are going to see about the permanent magnet moving coil instruments. What is measuring instruments? I have two electrical supply, one is AC and DC. Can I use the same instrument for measuring the same that is DC and AC? No. For AC, separate instrument is needed. For DC, separate instrument is needed. Okay. So the moving coil instrument which is used for the DC measurement and moving ion instrument which is used for the AC measurement. Okay. So this is the PMMC, permanent magnet moving coil instrument. Permanent magnet moving coil instrument. So here it has two poles, two permanent magnet. There are two permanent magnet. One is north pole, another one is south pole. So in between the north pole and the south pole, so there will be an cylindrical or rectangular shaft coil will be there. So and spine piece will be there. And in this we are mounting the coil. Okay. Now, so this is nothing but pivotal jewel bearing which is used to reduce the friction while rotating the pointer, and this is nothing but here also one spring is there. Okay, and this is nothing but balance weight, and there will be a control weight is also there, and this is nothing but needle which is moves across the scale pointer. Okay, so here, so during this operation, here the supply is given into the permanent magnet. So here the flux will be produced from the north pole to south pole. So here in between the core will be there. So the core will be gets attracted by the attracted, and or it will be gets repulsed based on the polarity of north and south pole. If you north to north, it will be gets repelled. It's based on the magnetic power. So this current, the supply is given into the coil is also gets energization. So based on the quantity which is supplied to the coil, here the deflection is gets deflected different. So if the current is too low, it will induce some of the magnetic power and it will be slightly moving. So if the pointer gets mobile, the needle gets more rotating. So the pointer is connected in the needle itself. So the pointer also gets moving. Okay. So just you can see this. This is the fixed coil, and there are two fixed coil, north pole and south pole. Those who are the permanent magnet, and center one is the moving coil. The moving coil gets movable according to the repulsion force which is induced between the permanent magnet and moving coil. So based on that, the pointer and needle, everything gets movable across the scale. Okay, so these are the simple schematic diagram, small animation. If the circuit is closed, the current will flow so that the pointer will move. If the circuit is open, there is no flux production, so it will be in a rest position. Okay, so it operates under the principle of motoring principle only. Okay, so there are three torques are needed to produce the to move the pointer from 0 to some value. That is nothing but deflection torque. Already we seen what is deflection torque, controlling torque, and damping torque, etc. So now we can compare. What is the compare, and we can say the advantage and disadvantage. So the advantages are it consumes only low power, their scales are always uniform, and there is no hysteresis losses is produced. And the disadvantages are somewhat costlier as compared to the moving ion instrument, and it cannot be used for the AC instruments. The friction and temperature might introduce error in case of other instruments. And it has two types of instrument. One is attraction and moving for the moving ion instruments. So attraction type is based on the attraction. So here while supplying the current, it will be act as a north pole and it will be south pole. So the ion piece will be gets attracted during this attraction. So the entire piston is gets mobile. So if the entire structure is gets mobile, the pointer is gets rotating. Okay, so it is based on the attraction with it. And this is nothing but a repulsion. It consists of two types. One is radial and coaxial. It is based on this structure. Okay, so here based on the repulsion principle. So the two are the north pole and two are the south pole. one is the fixed one is the fixed one, and this is the movable one. Okay, so based on the current, the movable plate, okay, of the northbound southbound bodies gets a ripple, be a ripple. So based on the ripple, the pointer gets movable as well as the needle gets rotating. No, if the needle is rotating, the pointer also gets rotating. So the advantages of a moving iron: it can be used for both AC and DC, and high operating torque, and robust and simple in construction, highly accurate. Okay, no series loss is there. Okay, there are many advantages, but the disadvantages is scale is not uniform. Okay, for low power range, power consumption is higher, and errors due to the frequency changes are it may be occurred. Okay, this is the assessment. So put your answer in the comment section, and that's it. And these are the few references for this topic. Thank you.